Have you ever experienced a summer barbecue get interrupted because it started pouring rain? Or maybe school got canceled because it snowed a ton the night before? If so, you've experienced what meteorologists call precipitation, which is basically their word for stuff falling out of the sky. But what if I told you that there are several more types of precipitation beyond your typical rainstorm or snowstorm? As it turns out, there are several more ways that water can come crashing back to Earth, and they all have their own unique impacts and effects. Now, before I get into falling water, I'd appreciate you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Okay, so let's start with the most watery of all of these types, rain. If you watched my video on the types of clouds, you'll remember that clouds are basically formed when water vapor rises into the atmosphere and condenses once it reaches a certain altitude that is dependent on a variety of factors such as air temperature and humidity. As the cloud grows, the water droplets within it will slowly start merging with each other, growing bigger and bigger. Eventually, these water droplets become too heavy to be carried by the air currents in the upper atmosphere, so gravity takes over and the droplets fall to Earth in the form of rain. Typically speaking, the more moisture that's in the air, the more droplets that are able to condense and fall back to Earth, and the heavier the rainstorm is. Oftentimes, warmer air, such as what's found in your typical afternoon thunderstorms, is more conducive to holding more moisture and thus heavier rain. But this is no hard and fast rule by any means, and heavy rain in cooler weather is definitely possible. Fun fact, raindrops are actually not shaped like teardrops. What happens is that the droplets in the cloud assume a spherical shape due to things like surface tension, and as it falls down, air resistance from beneath causes the bottom to flatten out. As a result, raindrops are really shaped more like hamburger buns by the time they actually reach the ground. However, the fact that rainstorms are really just a bunch of liquid water falling from the sky in warm conditions makes them not really that interesting in the grand scheme of things, so let's move on. Okay, now let's look at something that looks like rain, but really isn't. One of the most destructive types of winter weather that can happen in the southeastern US is known as freezing rain. And this is what happens when you start adding a layer of cold air into the mix. Typically, the atmosphere looks like this. Warm air is closer to the ground, and colder air is higher up in the atmosphere. However, there are things like inversions and warm fronts that can flip this gradient on its head, with warm air actually being higher up in the atmosphere and colder air being trapped near the surface. When the system is at the right temperature, the layer of cold air near the surface will be below freezing, while the warmer air above is warm enough to keep the precipitation liquid. If this layer of cold air is shallow enough, the rain can stay liquid all the way until it reaches the ground. However, since the ground is so cold, the rain freezes instantly on contact. This can happen to any surface as long as it's cold enough, and that includes everything from trees to roads to power lines. And the more rain that falls, the greater the ice accumulation gets. As you can probably expect, this can wreak havoc on the power grid from fallen limbs and power lines, as well as people's ability to actually drive since pretty much every road is turned into an ice skating rink. These types of storms are most likely to happen in areas that frequently hover around the freezing point during winter storms, which includes a belt of states that roughly stretches from Oklahoma to North Carolina. However, pretty much anywhere east of the Rocky Mountains can get these storms in the US, since a shallow layer of cold air can easily move south and makes for the perfect setup to actually create freezing rain. If ice accumulation is thick enough, the glazed over roads and power lines can shut down entire cities for several days, and even going outside can become extremely dangerous. Thankfully, such storms only happen once or twice a year in most places, and they can't happen at all west of the Rockies since it's much harder for a shallow layer of cold air to move south. The next couple types of precipitation start moving away from being liquid water and instead become more like ice. Remember how freezing rain is basically a shallow layer of cold air near the surface with warmer air up high? Well, what happens if we expand the layer of cold air, such as precipitation, and initially starts out as liquid, but has enough time to freeze before hitting the ground? This is what's known as sleet. Sleet tends to take on the form of tiny ice pellets, not totally dissimilar to the spherical water droplets from which they started falling. Since they are individual objects as opposed to one huge sheet like ice accumulation, sleet piles up in a fairly similar way to snow does, with the main caveat that they are significantly heavier, so they take longer to clear away and they take a lot longer to melt. The pellets themselves are extremely small, so they don't actually cause that much damage. However, I would be remiss to make a video on precipitation without mentioning what is possibly the most damaging type there is: hail. Unlike freezing rain or sleet, Hail actually doesn't need cold air near the surface to happen. Instead, water droplets can get carried into extremely high parts of the atmosphere, where they can freeze and coalesce into massive hailstones. These hailstones then fall back to Earth at breakneck speed, so they usually don't have much time to melt before reaching the ground. Hail most often happens during summer thunderstorms, as these are the clouds that can carry water droplets to such extreme heights in the first place, so they usually melt extremely quickly on reaching the ground. However, if it's hailing hard enough and the temperature is cool enough, it too can accumulate on the ground some more to snow. Since hailstones can get so massive, they can punch holes in the roofs of cars and some ceilings in severe cases, which all told can cause billions of dollars of damages over a wide area. Thankfully, this is usually only an issue for the worst hailstorms, and your average hailstorm will barely cause a dent, pun intended. Okay, so we started off with precipitation that was liquid all the time, then precipitation that was liquid until it froze at the end, and then precipitation that started liquid but freezes in midair. There's only one type left to explore. What if it's frozen the entire time? The answer, as you probably guessed, is snow. One interesting thing about snow in general is that, unlike the other types of precipitation I've talked about, snowflakes are able to have quite intricate and beautiful patterns. This is because as frozen ice crystals start to descend from the sky, it is possible for water vapor to freeze as it comes into contact with them, which is able to create these patterns over time. Since each ice crystal takes a slightly different path to the ground and thus encounters very slightly different conditions in regards to temperature and humidity, the patterns that end up forming will be different, which gives rise to the belief that no two snowflakes are ever exactly the same. However, given that there are quite possibly billions of snowflakes that fall to Earth every year, and the fact that snowflake patterns still fall into a few general categories, I find this extremely hard to believe. Another interesting thing to note is that how it can easily snow at temperatures several degrees above freezing. This is actually a similar situation to freezing rain, except here it's a shallow layer of warm air near the surface instead of cold air. This means snowflakes won't have time to melt before they reach the ground, though oftentimes if it's significantly above freezing, they just won't stick. Unlike freezing rain and sleet, which are nuisances at best and can be pretty damaging at worst, snow is oftentimes extremely beneficial in the places that have it. Not only is snow crucial for the skiing industry around the world, mountain snowpack is oftentimes the primary source of water in generally drier climates, such as the western US. This is because the snow will build up during the winter, then melt off into rivers and streams in the spring and summer, which go on to provide crucial drinking water to numerous cities and towns. And of course, if it's snowed enough, people might get a day off of school or work. And that's all I have to say about precipitation. As always, I'd appreciate if you like the video, subscribe to the channel, and hit the notification bell to stay tuned for future content. Thanks and have a great day.